hope all you are safe and fine at your own homes. And yeah, it's been a few months. We met together, we talked together, we studied together, we played together and everything. Yeah, soon we will overcome this great pandemic COVID-19 in a very better way. And of course, even these online classes are a great solution for overcoming the pandemic. And let me come to my subject today. Today I am in front of you with a physics seminar based on the first chapter, and I am dealing the topic Coulomb's law. Yes, Coulomb's law is a topic we have already learned in our previous classes, which means in 9th standard, 10th standard, 11th standard, and now even in the 12th standard we will study about Coulomb's law in a very detailed way. Okay, so let us move. If you have textbook with you, please just keep in front of you because I speak with respect to our textbook. In the page number 10, almost just after the half, you can see a bolded title, Coulomb's law. Okay, let us go through the first statement of our textbook. Coulomb's law is a quantitative statement about the force acting between 2 point charges. Okay, Coulomb's law is a quantitative statement. What does it mean by quantitative statement? Quantitative statement means a statement which is having measurements and numbers both in it. So Coulomb's law is a quantitative statement, which means Coulomb's law is having both numbers and measurements in it. Okay, let me tell you one history. A 4-line history actually. In the right side of the 11th page of our textbook, in a blue box, we could see a short history. Our textbook speaks to us it in a very complicated way, but don't worry, I'll make you interested. You know, in 18th century, scientists knew about the force exerted by a charged particle to another charged particle. Okay, they understood this. But you know, they were not knowing or having any idea of the strength of the charge. They were clueless, which means they were not having any clue on the various factors that affects the strength of the charge. Later, this problem was solved by Charles Coulomb by famous Coulomb's law, and that is what we are going to study now. So what is Coulomb's law? In the very basic, we could say Coulomb's law provides a basic idea on the electricity in physics. Coulomb's law mainly look at the two forces which is acting between 2 point charges. Okay, let me show it you in a very visualized way. This is both of my hands, right? So I just fold my fingers and suppose both these are charges. Okay, point charges. This is charge Q1 and this is charge Q2. If the distance between them increases, you know the field and the strength of the field and the force decreases. Okay, now what I have told you, this is Q1 and this is Q2. You know, the distance which separates this Q1 and Q2 is R. So the distance is denoted by letter R, small letter R. Okay, and then the magnitude of this force is then given by F is equal to K into Q1 Q2 divided by R square. Okay, I will show you. What I have told you. F is equal to K into Q1 Q2 divided by R square. So before coming to the explanation, let me come to the statements of Coulomb's law so that it would be somewhat a little bit easy for us to compare the equation and statement. Okay, let me say the statement. Coulomb's law states that the force of attraction or repulsion between two forces is directly proportional, okay, listen my words, directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Okay, don't worry, I told you this is Q1 and this is Q2, so that is, the F is directly proportional to the force, okay, the force is directly proportional to the magnitude of the product of the charges. So product of the charges means this is Q1 and this is Q2. So product. So Q1 into Q2. So from that statement what we would get? Yes, F is directly proportional to Q1 into Q2. And what is the next statement? Yes, what? Inversely which means what is the distance? I told you like before, r, and square of the distance will be r square. So f is directly proportional to 1 by r square because inversely proportional. So it will be 1 by r square. I have told you. Here you can see f is directly proportional to q1 into q2 and f is directly proportional to 1 by r square. So by comparing both of this, we will get or we can conclude as f is directly proportional to q1 q2 divided by r square. In such a way, f is directly proportional to q1 q2 divided by r square. Now, let us change the proportionality symbol to equal to sign as we do in every equations. And then what we would get? Yes, we will end up with a constant there. So in this case too, there is a constant k, and that k or that constant is known as Coulomb's constant. I'll show you. Okay, this is that. So here it is changed to equal to sign. So f is equal to k into q1 q2 divided by r square, where f is equal to electrostatic force and q1 and q2 are both the charges. K is Coulomb's constant and r square is the square of the distance between them. Now, I have told you these both charges which I shown you in a visualized manner, these two charges were in vacuum. So in vacuum, in vacuum k is having a value. The value of k in vacuum is 1 by 4 pi epsilon 0, which means you can see here 4 pi epsilon 0. This is written as E and in bottom just a small 0. So it is read as epsilon. Epsilon 0 is a new term for us. Epsilon 0 is also called permittivity of free space. Epsilon 0 is also called permittivity of free space. And that's it. Now, this epsilon 0, epsilon 0 is having a value. Epsilon 0 is having a value. And the value of epsilon 0 is 8.854 into 10 raised to minus 12 c square n raised to minus 1 and m raised to minus 2. That is the unit of that. Okay. So, we have to study in by heart the value of epsilon 0. What was it? 8.854 into 10 raised to minus 12 c square n raised to minus 1 m raised to minus 2. And that's it. Now by substituting the value of epsilon 0 there, we would get a solution or we would get answer for the value of k. So we can find the value of k there. So by substituting what we will get 1 by 4 pi. What is the value of pi? Yes, the value of pi is 3.14. 3.14 and epsilon zeros I have already told 8.854 into 10 raised to minus 2. So by calculating this in your calculator, we would come to an answer that 9 into 10 raised to 9. So in SI units, the value of k is 9 into 10 raised to 9. That's it. Now by substituting this 1 by, here it was k, right? Here it was k. So k's value we have ended up with 9 into 10 raised to 9. So by substituting the value of k here, 9 into 10 raised to, it would become 9 into 10 raised to 9 q1 q2 divided by r square. That's all about that. It's very simple, right? Now, let me conclude my class, but before that one more thing. Since force is a vector, it is better to write the Coulomb's law in vector notation. Okay, this is a simple view of our textbook. It is clearly given in our textbook how the Coulomb's law is written as or in a vector notation. And that's all about that. My dear brothers and sisters, hereby I am going to conclude my class. Hope all you understood what I have told, and may God bless all of us. Stay home, stay safe. Thank you. Have a nice day.